here to see my talk on analyzing scroll performance. And I'm Eric. I'm an Android engineer at Tumblr. And what I've been doing over the past 6 months or so, I don't know, is working on analyzing scroll performance, obviously improving it after I analyze it, and hopefully making the scroll performance of that better. Cool. So what is scroll performance? It's composed of behavior. So basically like how the user scrolls. I mean, users are not going to scroll the same way every time. They're sort of like scrolling up and down. They're scrolling really quickly, really slowly. Who knows what they want to do. The content that you want to display to them. So, I mean, obviously on different screens, you're going to have different content, and that's going to impact your performance. So the behavior impacts performance, the content, and the device. I mean, there's old and there are new devices. And sort of this, like, the Facebook talk earlier today talked about how they broke down between different devices and how they do telemetry to sort of get a really good, big, aggregate overview of how their app performs on different devices and with different users, because obviously users in other countries or whatever may use the app differently than you might. But this talk is a little bit less about that very broad general overview, and more about once you think your app is slow, which your app probably is slow in scroll performance, what can you do and to figure out what is the thing that is slow and actually fix it. So I'm mainly going to focus on recycler view because if you have scroll performance issues, it's probably because you have a very, very long list or an infinite list. And a recycler view is a great way of immediately improving performance over a linear layout or whatever you use to display your data. And Lisa earlier today also briefly went over how a recycler view works. But basically you have to create new things at the bottom and you remove things at the top. And on create, you have to inflate the new view, and then you have to bind it with the data that you want to show, and then you add it to the bottom, and then when it gets removed at the top, it gets added to this pool with, I think, like 5 items per view type, and then when the same view type shows up again, it just gets bound again. So it's like a basic overview. Obviously, there are many talks that really get into detail about how recycler view works, but we're here to focus on measuring the performance of that recycler view and the performance of your app. So measuring is what you need to do to figure out if your scroll performance is good or bad. And one of the ways that, as mentioned earlier in the Facebook talk, is that you can use systrace, which basically generates this flame graph. And they had a similar tool, which apparently wasn't systrace, but also generates a similar sort of thing where you go through each of the methods, and it tells you, oh, this method, say input here, or choreographer, took X amount of time, so on the x-axis is time. And as those methods call other methods, those methods take a certain amount of time. And this is a good way to sort of like dig in and see, okay, what are the methods that are slow? But, I mean, generated a systrace file for like 10 seconds of scrolling, and it was something like 8 megabytes. And I hope your user uses your app for more than 10 seconds, maybe 10 minutes even, and I wouldn't want to open that file because it may never load. Also, another part of this is that the UI thread and the render sort of interacting with the GPU thread are 2 separate threads, and you'll see that in your systrace. So the other thing I want to talk about, I'm mainly going to focus on, is the thing that they added in Android Marshmallow, which is frame stats, and it roughly correlates to something they had earlier called graphics info. But basically, frame stats goes and tells you how long each component of rendering your frame took. So start is something that should be really small, and that's basically anything that was blocking your UI thread, starting from vsync. Input is your device handling, like, oh, the user was touching the screen, and it has to figure out which view you touched. Was there an on-click? And as they go and move the views, maybe inflate new views. And then when you are flinging the recycler view, right? You're no longer touching the screen, but the recycler view is still scrolling. So that's going to fall under animations, and still going to be inflating and binding new things. And also on every single frame is going to go, or not every single frame, but on many frames, when you're adding new things to your layout, it's going to have to do the layout and the measure pass, and then it's going to have to draw, called view.draw. And then after it draws, it's got to send that to the GPU, and the GPU is going to draw that. And this roughly, so each of these things roughly correlates to the same information in graphics info. So draw is all that work on the CPU I was talking about. Prepare is that sync phase. And execute and process are just two little bits of information about what the GPU is doing. So execute is like executing display lists. Colt McAnlis has like a nice little short video on this process. And execute is going to be where like your overdraw shows up, because that's like, okay, now if you have alpha issues, it's going to have to double buffer and things like that. And process is it actually doing that drawing. So this also roughly correlates to what's happening on the CPU and the GPU. And there's going to be a little bit of time to transfer, like if you have a large bitmap, or 10 large bitmaps, I don't know. It's going to have to transfer to the GPU, and that's going to take some amount of time. And you don't have infinite bandwidth. And so it's going to depend on the device how much bandwidth you have. So this basically, systrace is that same information that framestats shows. So framestats shows it vertically, right? One frame here is vertical, but and the y-axis in this graph is actually time, and the x-axis is one frame. Systrace basically says like the x-axis is time, and then on every one of those lines is going to be your vsync, and also the rendered thread is separate from the main thread of your app. But there's going to be some little overlap. I wouldn't worry too much about it, because you're probably not going to go and optimize whatever it's doing to the GPU unless you're writing some OpenGL. So what happens on a slow frame? Well, basically you miss a vsync, right? It's not like if your frame takes more than 16 milliseconds to render, it's going to go and like immediately draw that frame once you're done. No, it's going to wait until the next 16 millisecond, sort of 60 hertz interval has been reached, and then it'll draw the frame. So this is what is meant by dropped frames. That frame in the middle, you've dropped. It just drew the same thing or didn't draw anything new to the screen. Cool, so what does that previous slide look like in framestats? Well, you've gone past the 16 millisecond threshold, and you can see this when you're scrolling with framestats on, or you can make it show like ADB dump graphics info on screen as bars. And this will, and then in the newer versions of Android, they make it a little bit bigger. That way you can see that, oh, you've like gone over the threshold. And then when you've gone over the threshold, the user perceives it as jank, right? And this is what you see on your device. You get all these colorful lines, and somehow this data means that your app is slow, probably. So you can see in a couple places here, we've gone over 16. And well, all that data is like kind of hard to parse. You only see like maybe like a second of that data on the screen, so you can take that same data, turn it into a histogram. So basically, you have this slow frame in the middle or near the middle, and it correlates to that green square all the way on the right. So it's basically counting all the slow frames and sort of bucketing them. Well, I just basically explained what a histogram was. But basically, you want to keep as few frames over 16 milliseconds as possible, right? But I think another way to look at it, I think, is a little more meaningful than just looking at it as a histogram, is to take that same information, the frame stats data, and sort it from slowest to fastest. And basically, it's the same information, right? So what's on the left means that like these were the slow frames. So correlates. It's like almost the reverse of this histogram. But basically, like the reason why I like to do it this way is because all your fast frames, you're going to have a lot of fast frames if you scroll for like 2 or 3 minutes. So you can kind of sort of ignore those and focus on the ones that are slow because the users really feel that as jank. Cool. So if we ignore that, the breaking up of the frame stats data into its individual components, you get this nice little curve. And similar to what they mentioned at the Facebook talk, 50th percentile in the middle, just the median. And so you want to look at the different percentiles because they really do mean different things. Sometimes your 50th percentile can be really good, and then your 90th is like not so good. So that means you have a few slow frames. If your 90th percentile is really bad, then you have a lot of bad frames. And also your 95th. So basically what these percentiles are really describing is the shape of your graph, the shape of this frame stats curve when it's sorted, right? Cool, so jank is everything in this sorted graph that's over 16 milliseconds. So what we would like to do is just go and optimize the slow frames away. Like if you're over 16 milliseconds, just don't do that extra work. But unfortunately, it's not that easy. Oftentimes, you're doing a lot of unnecessary work on every frame. Maybe you have overdraw. Maybe you have, I don't know, you're creating allocations in ondraw or something. So one method is to like not do that unnecessary work on every frame. And then that might partially solve or mostly solve your jank issues. Or you can also take the work that the excess work you were doing on those frames and move it to another set of frames. And this is possible because just because you drew a frame and rendered a frame in 8 milliseconds does not mean like it just goes and renders the next one. It just waits until it starts the next frame. So you do have some extra time to sort of go and do other work. But 16 milliseconds is not a lot of time. You can't go and download a file in 16 milliseconds. Maybe not yet. So you can move the little bit of work that you are doing on the janky frames and try to move it to these faster frames so that you have that smooth experience. So it looks something like this, and you'll be under 16 milliseconds. You'll have that 60 FPS buttery smooth experience. But let's take that same data and look at it another way. Let's sort it upside down. Let's take the components and turn them upside down. Well, now the bottom, the GPU sync and draw work is pretty much work you have to do on every single frame, right? The user, like maybe you didn't do any inflations, you didn't do any binding, but the user is just touching the screen and moving it like 1 or 2 pixels. And sometimes you can just do that on your app and see like, oh, wait a minute, like I'm just moving it 1 or 2 pixels, but it's just taking like 8 milliseconds to draw that frame. So that's work that's done all the time, and if that's taking a very long amount of time, then maybe that's something you should optimize first. Traversals, like the measure and the layout pass. I think in the documentation it says this should be like under a millisecond or something like that. It was not a lot of time. And it's going to be running this on most frames because you're going to be adding and removing things from your layout. And the less frequent work is like you're doing, I don't know why you're doing work on the UI thread, but sometimes you have to. And that's going to be blocking. Hopefully you're not doing too much stuff. Input and animations, when the user's actually touching the screen, when they're actually scrolling, that's also work that's going to happen, and maybe not on every single frame. And that's going to cause some jank. So I wrote a small little Python script, basically, that takes that frame stats information. So right now, when it dumps it only dumps the last 120 frames. And Slicker is this small little script that will go and aggregate that data across many, many sessions of running that dumps this frame stats. And then you can, because 120 frames is basically only like 2 seconds, right? Because you have 60 frames per second. And if you want to scroll for like 3 minutes and then aggregate that data, you can use Slicker to do it. And it'll generate data like this. I mean, I only have 120 in this screenshot, so I didn't prove that my script does anything. But it will go also sort it, and then it'll generate the histogram up on the top left. And it also generates this histogram of each component. And that's a really hard one to use because it doesn't correlate the frame that it happened on. It breaks it out and assumes that all the components are independent, which is usually not that useful. Because what happens on one frame is going to probably be one of those causal effects because something is slow, so it makes something else slow. But I left it in there. It looks cool. Cool. So this is me running Slicker on the Google Plus app. And it's OK. It goes over 16 milliseconds sometimes, so it's the green line. And you can see here that they have maybe 10 janky frames on the left bottom left. But their slowest frame is taking something like 2x, or it's dropping like 2 or 3 frames. Because it's over 16, and not only over 16, it's over 32 milliseconds. So, like I was saying before, what is jank? Jank is when you're scrolling, and the animations that input cause an inflate and a bind, right? Because the user's moving their finger up and down, and now you have to inflate a new view, or bind a new view, or maybe they're just fleeing, and that's also causing inflates and binds. And this is the real thing that really causes jank, because at the same time, you inflate a new view, that means you have to do your measure layout pass, you have to draw the thing, like you have to draw the new bitmap if you have a new bitmap, send it to the GPU, and the GPU has to render it. So basically, all this work that you're doing just like builds on top of each other because you're doing new work that hasn't been done before. So basically, the challenge is you can have many slow frames. So if you play video games, like you can have 30 FPS, or you can have a few very slow frames. And this is sort of the balance that you're trying to reach, right? Because you can basically try to spread out your work as much as possible, in addition to obviously don't do work that you don't have to do. Or you can try to like front load all your work and maybe, like a lot of games do this thing where they have the loading screens, right? And they're trying to do as much work as possible so that they don't have what in games they call micro stutters, where your game is like stuttering and you're trying to move, and then like all of a sudden like the screen freezes for like a second, and then you get like, I don't know, you move like 30 degrees or something, or like 30 feet in the game. So I think I prefer, if possible, many slow frames, or very slightly slower, because that means you can possibly reduce a little bit of the unnecessary work that you can do and keep yourself under 16. But also for a user, it just means that you're lagging a little bit. You're running at 30 FPS maybe. And in games, you can sometimes change your refresh rate to 30, and it's like a little bit worse, but it's not usually terrible. So when you have these infrequent, very slow frames, it's caused by often, maybe not all the time, depends on your app, bind and inflate. And when you have these frequent slow frames, the bind and inflate, you're inflating smaller views, hopefully, to sort of keep under that, to reduce the microstutters, right? So what causes these inflates and binds to take a really long amount of time? Well, if you open Hierarchy Viewer and you see that you're inflating like, I don't know, I think something like 13 views in this tree here, in this view hierarchy, like it takes something like 1 millisecond per view. I don't know what device I got that data from, but somewhere. And that's 13 milliseconds. That's pretty much leaves 3 milliseconds to do the bind and the traversals on the draw, and you're going to go over it almost immediately. So, and also, if you've ever made a selective view that basically has no content, I think the base amount of time it takes to do all the frame stats stuff is something like 6 milliseconds. So you really only have 10 milliseconds to do the work you do on inflate and bind. So the thing that you can do is split up your work into so that each frame does less work, basically. So now your inflates are smaller, your binding is smaller, you're binding less data on every single frame. Your traversals, I mean, you're basically going to be, if you actually display all this data on the screen at the same time, your traversals are going to take the same amount of time, and drawing may actually take less time because it's going to cache what it did in the previous frame. So basically, you're hoping that the work doesn't culminate into this one big janky frame because you inflated this like 13 view layout. So this is what it looks like in reality. You're taking these two large view holders and breaking it up into smaller view holders. So now I go from one view type to two view types. And I think Lisa showed something similar in her talk where she broke up the entire list that she had into individual list items with two columns. And you might also notice that in here, there are actually more views than there were before. There are more squares and rectangles than there were before. But the reason why this still works out is because if you have 3 of those things on the screen, because they happen to be, I don't know, aligned in that way, when you have smaller view holders, that means you can eliminate the parts of the view that you don't see, right? The parts of the layout that you don't see. So that, and also if you're recycling these, that means you can have fewer of them in your pool, and they take up less memory, which is nice. So you go from infrequent, very slow frames where you're inflating these larger layouts to more frequently slow frames, which I think is better. But how small do you want to make these view holders or these items? Well, I'm scrolling on my blog for about, I don't know, 7 seconds or so. And I generated a picture of how many pixels that was. I took screenshots and I just sort of merged them all into one big JPEG. And that's something like 18,000 pixels, vertical pixels. And that's also this on 5x, so it's like a 1080p screen. So it works out to something like 14 dp per frame, which is really small. And I don't advocate going and splitting an image view into 14 dp size chunks because the number of extra views is not going to result in better performance. But basically, like if you're making a layout that has a vertical linear layout in the same direction that you're scrolling, you probably want to break that up because that's work that you didn't have to do on that frame, right? So moral of the story is to do less work more often. You want to break that work up into multiple frames so that each frame you do less work. But it gets more complicated, right? You have many view types, probably. Like in that example, I went from one view type to two view types. And in the Tumblr app, for example, I think we have like, I don't know, 40-something view types. I wouldn't be surprised if any other complicated app has like, I don't know, 40 or 50 view types. So there's a lot of variety. So how do you break up your view types to even more view types? Do you do that? How do you reuse them? How do you know which ones to optimize? Right, because this is what it actually looks like. You're not inflating and binding the same thing over and over. You're inflating and binding different things, and you're doing that because you need to do that. You need to display something different on the screen. In this case, I'm binding the same thing, the second and the fourth one, but you want to balance something. You want to balance reusing and inflating new things. I don't know if you've ever seen the pattern when you just started out with a recycler view, but you jam everything into one view type, and then you like show and hide the ones that you don't need, and the ones that you do need, and then like your inflation time basically takes like seconds, but I guess when you're done inflating, it's not too bad. But what's also important is that that one view type, the second one, shows up twice. So the frequency of the view type also matters. And some view types are more or less frequent than others. So in this graph, I've added up the total amount of render time in this, like, I don't know, arbitrary amount of time. And you can see that, the simplest one, the middle one, took more time to render because it showed up twice. But on average, it took less time. But which one should you optimize? Like, it shows up more often, so like, why don't you optimize that one instead? And that would have a greater impact on your app performance, right? Well, I think my general recommendation, and this is like very sort of like rough rule of thumb, is to fix those frequent view types first, because very often you can change, well, not often maybe, but like you can change the content, or users will deal with the view types that are very rare. Like maybe it will probably be like, you're inflating in the beginning. This is like some special header that they see once in a while, or some special view type that they see once in a while, and they'll just deal with that. But if you have something that's like very frequent and also very slow, then the users are really gonna notice that first. But I don't know, this is a very complicated multi-dimensional problem, right? There's a number of types, there's the frequency of the types, and the render time for each of those types. And how do you have to balance all of these, right? And it all just comes down to developer time, right? If you could just rewrite the entire thing in OpenGL or some, I don't know, C++ or something, and I'm sure your app will be faster and terrible to work with for new developers, but I don't know. Maybe you're working on a game. But to make this even more complicated, your view pool, like I said, has by default 5 of each view type. And this is going to take memory. If you have 40-something view types, you have like 40 times 5 number of things in this view pool, and that's going to have some memory impacts. And maybe if you have a memory leak, hopefully it doesn't happen 5 times for every single thing in the view pool. So that's another thing you have to keep in mind, right? How much memory are you using to keep your scroll performance up to par and keep it smooth? Because obviously something on a lower end device is maybe you should have a smaller view pool. Maybe you should like adjust your number of view types or which view types you use. So another idea, like I mentioned earlier, is that you can take the same view type and reuse it. So do you reuse or do you recycle? Right, I mean, the name of the view is a recycler view, so maybe you might be a little bit biased toward recycling. So reusing is when you take a view, a view type that you have, and then maybe add or show or hide another view that you have, because maybe that item that you had didn't need that extra view. And recycling is when you take one view type and you don't show or hide anything, and then you create another view type for that other piece of content. But recycling is a little bit expensive because you have to inflate that the green view in the bottom right, right? That's a totally new view holder, so now you have to inflate that thing, and that inflation is going to cost something. Well, you could just reuse the one that you already have. But this to me comes down to complexity, because reusing is going to get really complicated if you're showing, hiding like 20 different things, right? So here, another idea that adds quite a bit of complexity is to inflate, but only inflate what you need to inflate. So the minimum amount of things. If you know that blue square on the left is always going to be there, no matter what type of content you're displaying, then you always inflate that. And you can also have a view stub that's just sitting there, ready to be inflated in your bind if you need it. Another important thing is that when you call onCreateViewHolder, when that gets called, you only get the view type. You don't get the model. You don't know what data you're binding to it, right? So when you actually when bind is actually called, you can take that view stub, inflate it. That's going to cost you an inflation, and then hide or show it once it's already inflated. And then like if it's invisible, it pretty much has like minimal like layout and measure and draw costs, right? So this can be better, but if you had a really complicated layout and you just had one view type and you had like, I don't know, 30 view stubs, that might get really complicated on your end. Another thing to think about is also as the user scrolls, basically where the work is done is going to change, right? When they first open the activity, you're going to be doing a ton of inflations because nothing exists, and then you're going to have to do binding. But inflation is going to take most of the time. And as the user starts scrolling, the view types that they have seen are going to be inflated, and hopefully they see those view types again. So inflation is going to happen less often, and binding is going to be a bigger portion of the time spent. And as you paginate and you get deeper and deeper, and maybe they scroll for 10 minutes or so, you may even have GC. So this is where, like, if you call new in onDraw or new anywhere, and you cause a GC, like that's going to cause like your inflate to take forever or bind to take forever, because especially if you see in your logs it says suspend all threads for 5 milliseconds, and that means you have only 11 milliseconds to do the work that you want to do. So that's why you really should inflate and bind as little as possible, because something like GC can just be triggered when you call new. Although generally it tries to find an optimal time, so it's not like that should be happening, especially if you have 3 gigabytes of RAM on a newer device. So another thing to think about, if you have the same view type, the same, and you're rebinding it or inflating it, inflation is pretty much going to take the same amount of time, right? Because you don't know what content you're going to be showing, because onCreate doesn't tell you that. So it's going to take, like, see, this like I drew a normal distribution. I don't know if it actually is a normal distribution. All right, it's going to depend a lot on the device, and maybe Facebook has the data for their app across all users. But bind time is going to also vary a lot based on the content, right? If you bind an empty string, it's going to take less time than trying to like call HTML from HTML on the main thread, I guess. I think we might do that, or we used to do that. And that could take more time depending on what you're trying to show. So it's quite a bit harder to figure out, okay, if I'm optimizing my bind time, well, I need to sort it by the content that I'm displaying. So then if you have user-generated content like we do on Tumblr, now you have this like very difficult problem where like someone can make a malicious or really long post, and that takes forever to bind. So if you're doing any sort of telemetry, like Facebook, you basically have to like throw that data out, or tell the server-side guys like, don't send me a text post with 5,000 or 100,000 characters. Or on your side, then you have to like do crazy amounts of developer time splitting up that huge string into smaller view holders. But maybe that content only shows up once every 10 minutes, I don't know. So basically you're looking at all these metrics to sort of balance where should you spend your time on. And because you can't optimize everything, right? So what do you focus on first? So layout complexity leads to longer inflate time, and content complexity leads to longer bind time. And so you want to break down what you are inflating and what you are binding, because you can't just aggregate that data necessarily, because not all the things that you're not comparing apples to apples. If you're not comparing the same view type with the same view type, or the same content with the same content. And this is why it helps a lot to have continuous integration, sort of get a rough idea if you're doing better or worse. But optimally, you would have something like what Facebook's doing with their telemetry and have a really good idea of exactly what, how the users are behaving with your app and exactly what you're showing to the users, right? What view types show up the most often and what content are they seeing the most often. So that's what you should optimize first. So I went through this entire talk so I can have this terrible clincher slide. Definitely the first thing you should do is reduce the amount of work you do. You should try to use view holders until it gets really complicated, and definitely recycle your view holders. Yep. So github.com, my name, Slicker, is the sort of little script that I wrote, and that's my Twitter handle, Eric W. Leong. And yeah, I think I posted the slides on the Slack, so they should be on the internet. I don't know if anyone skipped ahead and ruined my talk in Slack. Cool. Are there any questions? I think I have 4 minutes or something.